Welcome to episode 2 of PNW Weather 101. I'll be going over how tropical cyclone remnants affect us and how severe those effects can get, and a few particularly odd tropical cyclones, including the one in the satellite image in the background here, and if there's any shot any of these weird systems could make landfall even on a 1 in 1,000 year time scale. So first off, I'll go over what a tropical cyclone typically needs to maintain as a tropical cyclone. You need generally 26.5 degrees Celsius or higher sea surface temperatures. However, there have been documented cases is where lower sea surface temperatures can be sustained if sufficient upper level divergence and or cold temperatures in the upper troposphere is present. You also need a disturbance of some sort. So storms forming south of 25 degrees north typically are done via tropical waves, which come off the coast of Africa in the northern part of the intertropical convergence zone, which is an area in simpleton terms of disturbed weather that commonly produces rain. Storms forming north of 25 degrees north are typically extratropical cyclones, which is the same thing as a mid-latitude storm that we tend to experience here in the Pacific Northwest. They will transition into a tropical cyclone. On typically a upper level disturbance is required for this to happen. A lot of times they can still be embedded within said upper level disturbance, which would create more of a subtropical cyclone rather than a tropical cyclone, though it can transition to tropical later on in its cycle. Also, you need low wind shear, which is the opposite of an extratropical cyclone, which generally needs higher wind shear, which is what the jet stream typically provides. So all of this typically goes against tropical cyclones, making it up to really anywhere north of 35 degrees north, and in the eastern Pacific Basin, anywhere north of about 20 degrees north, except for a pocket around Hawaii as sea surface temperatures get a little bit warmer, as you could see on the sea surface temperature map. The 26-degree mark is right at the solid yellow transitioning into the yellow-green, which for the Eastern Pacific Basin is right around Baja, California in the month of September. I ripped this straight off of the same slide that I used for the thunderstorm video 2 months ago because September is the month where ocean temperatures are typically at their warmest in the northern hemisphere. Off our coast, we typically see temperatures closer to around 15 degrees Celsius than the warmest times of year, which is translated to about 59 degrees Fahrenheit. So that's one reason why we don't get hurricanes off our coast on top of the wind shear versus the East Coast can. We can get remnants, though, of tropical cyclones, as it's not uncommon for a tropical cyclone in the Western Pacific. It's known there as a typhoon, going up and curving back into the Pacific and transitioning into a extratropical cyclone. And as it does so, it can get embedded in the jet stream and we can get its remnants. That is going to be happening the next couple of days with former Typhoon Kong-Ray. I do not expect that to be a significant system in our area, minus a few isolated impacts that most of these storms tend to do in the upper elevations when it comes to wind, especially. Other things that the remnants can do is the stronger ones can bring wind and heavy rain with them, but because they no longer have the tropical characteristics, it's hard to distinguish them from our typical mid-latitude cyclones. However, there are some tropical cyclones that have transitioned into non-tropical cyclone that can be pretty significant. Most notably, the Columbus Day storm of 1962 was Typhoon Frida, which, while a typhoon, it was a Category 3 equivalent storm with 115 mile per hour top winds. And when it made landfall on Vancouver Island, and as it was going up the coast to said landfall site, peak sustained winds in Portland were recorded at 88 miles per hour, which is the highest Portland has ever seen. It's the only time it's hit hurricane force sustained wind speeds, while gusts on the surface has reached 145 miles per hour, which is equivalent to Category 4 or hurricane middle end. Up at Mount Hebo, they did record 170 miles per hour for wind gusts. There have been more recent significant tropical cyclones, remnants that have made landfall. 2016 had former Typhoon Sogna, which a storm just in front of it caused the Manzanita tornado back then, which was the last EF2 tornado that Oregon has experienced. Now, onto our peculiar set of storms. So there's three that I want to take a look at. So first off is the 1975 Pacific Northwest Pacific Northwest hurricane, excuse me. Second is the 2006 Central Pacific cyclone. And then the third was a extratropical cyclone that had subtropical characteristics between the 24th and the 25th. It affected our region on the 25th to the 26th, so I took the middle date of that. I will start with the Pacific Northwest hurricane, as it was the only hurricane that has officially formed north of 35 degrees north in the central or eastern Pacific Basin, and north of 40 degrees north, only Hurricane John back in 1994 has maintained hurricane status to that latitude in addition to this hurricane. It maintained hurricane status to at least Eugene's latitude, which is right where my fake laser pointer is, trying to draw the straightest line I can. I know I'm not doing a good job with that. Eugene's latitude is about 44 degrees north. It was officially a tropical cyclone to 54 degrees north, and that's using the National Hurricane Center's best track. And I'm including on the left the satellite image of the storm as it was right around Eureka, California's latitude. So right in this second whitish dot, which that signifies Category 1 hurricane intensity compared to the lighter blue dots, which is just tropical storm intensity. In the Eastern Pacific hurricane seasons, most storms tend to be in this general area off the coast of Mexico that you could see where this huge cluster is. That's pretty typical, with a few storms getting into the Central Pacific Basin. So for it to being way to the northwest of everything else in 1975 is an oddball on its own. And if it wasn't so chaotic, including a larger map of every recorded Northeast Pacific storm, would be even more telling of how unusual this was. Now, for the unofficial, tropical cyclones, let's start with the 2006 Central Pacific cyclone. This, at the time, was unknown whether it was a extratropical cyclone, a subtropical storm, or a tropical cyclone. A study in 2016 that I am linking in the description confirmed this to be a tropical cyclone. It formed over 18 degrees Celsius waters at 41 degrees north to 42 degrees north. It peaked at 17 degrees Celsius waters, and translating that into Fahrenheit, that's 62 to 64 degree Fahrenheit waters, which is colder than most, if not every storm in the Atlantic, as I could find evidence that some storms have formed as low as 20 degrees Celsius with decent upper level support. It also had max winds of 65 miles per hour and 989 millibars for the central pressure. I'm noting this because the central pressure took the reading off of a buoy that was not at the center of the circulation, and it did not adjust it. It also did not get measured by the Dvorak technique, which is the standard technique used via satellite imagery to determine the wind speed of a tropical cyclone. If that is used for a non-tropical cyclone or a subtropical cyclone, it tends to underestimate the wind speed. So it is possible that the central pressure was lower, possibly about 985 millibars at the lowest. It's also possible that wind speed was higher. I will also mention that it did make landfall in Washington as a non-tropical cyclone with sustained winds on the coast going up to about 60 miles per hour in some of the capes, which is tropical storm force winds. On top here, I ripped this straight out the study I'm linking in the description. I believe this is their figure 1 or figure 2 without it being in front of me. So on top is the satellite image of the tropical cyclone on November 2nd, 2006, taken right as it was crossing into Oregon's latitude, and at the bottom is the sea surface temperature map. One thing I will note is that as this would get closer to Oregon and Washington, it would move over progressively lower sea surface temperatures due to that California current, which hugs our coastline. As a result, you would need increasingly more favorable upper level conditions to sustain a tropical cyclone structure or all the way to our coast. Therefore, even if a peculiar storm forms out here, I find it extremely unlikely for one to make landfall in Oregon or Washington, unless if the California current were to somehow shut off for any reason. I don't see that happening anytime in the next 10,000 years, for what we know, at least right now. For comparison, on the left here is Hurricane Vince, which formed in the Northeast Atlantic and made landfall in Spain as a tropical depression. And on the right here is 1991's Hurricane Grace. I chose both of these as comparison because these are both compact tropical cyclones with larger than normal eyes in the case of Hurricane Vince, very similar to the eye in this tropical cyclone. And then 1991's Hurricane Grace didn't really have an eye, but it was closer associated with the cloud shield that is present to the north of our 2006 system. Hurricane Grace was a Category 2 hurricane, and Hurricane Vince was a low-end Category 1. I will note that a vast majority of time, if not almost universally, an eye does signify that a tropical cyclone was at least hurricane force. I believe there are a few exceptions to that, but I cannot think of any off the top of my head. All right, so I have switched over to the Zoom Earth satellite imagery, which takes the NOAA satellite imagery from the GOES satellite and makes it a little bit easier to digest in terms of being able to move it backwards and forward as I see fit, which I find very useful in what I'm about to show you. So this is the satellite imagery taken on October 23rd, and I'm looking at this system right here off the coast of California, which looks like a typical extratropical cyclone with that comma-shaped appearance and the front in front of the cyclone, pun not intended there. If I move this forward a day, especially if I zoom in, can note the center of circulation and is right near where this cloud shield is, and there is a large dry slot of cooler and drier air around this ring of central convection, although it's not a complete ring. Now, central convection is more of a characteristic of tropical and subtropical cyclones rather than an extratropical cyclone. Most of the convection in the extratropical cyclone would be associated with the fronts because it's fueled differently. It's fueled via differences in temperature in a lot of cases compared to tropical cyclones, which I discussed earlier in the video. On top of that, if I go over here, so this is the wind shear map taken on that day at about this time. So about 1:20 p.m. I believe this is Pacific time, but I have no way to confirm that yet. And it shows that right in the area where this storm is, there's pretty low wind shear, which also signifies that it may have been able to gain some subtropical characteristics because of the fact that it was low wind shear. And then moving on to our other image, this is an scatterometer overpass, which was taken earlier that morning, showing that the peak wind speeds were pretty close to the center of circulation, which is right about where my mouse pointer is, versus the peak winds are about 20 to 30 miles to the west with these flags right here. A flag when looking at a wind barb signifies 50 knots. 50 knots translating to miles per hour is about 60 miles per hour, which is about a middle of the road subtropical storm strength if it was there. The reason why I'm mentioning that this is a subtropical storm and not a tropical storm is one, I can't even confirm that was a subtropical storm before I go any further, is that two, because it is still co-located with a parent disturbance, the upper level low here, that rules out it being a tropical cyclone as it does feature the hybrid characteristics of fronts and the, for lack of a better term, I'll use the pun I did not intend to use again, in front of the cyclone. However, if it can be proven that the central convection here was independent of these fronts for at least a little bit of time, maybe a case that this could be a subtropical cyclone, at least briefly. Because let's advance this another day. Yeah, this does not look healthy anymore, and it looks like it's merging with the system up north. And on October 26th, it's affecting our region now, but you can't even make out the surface circulation compared to this bigger circulation up in the North Pacific. And then rewinding this to where I had it before, that system is still very healthy up on north and would absorb this. The other question is, was the cloud shield to the north starting to get absorbed by that, which allowed that extratropical cyclone to gain those few subtropical characteristics? Something that could utilize some future studying in addition to the 2006 Central Pacific cyclone's strength. One thing I also want to point out is that this is unrelated to the PNW, and is that this is the North Atlantic Ocean on November 1st, and this is the extratropical cyclone that would become subtropical storm Patty. So if I advance this a day, you can now see that that central convection has completely decoupled from its parent upper level low. And quoting the National Hurricanes Center's Advisory 2, they say that the storm has a considerable amount of cool and dry air wrapping around the core, and it is co-located with an upper level low. The upper level low is signified by the cloud shield in front, which is similar to this storm here, but it does look like that this storm closer to us had more of the cloud shield wrapping around the central convective area. So as a result, this was a subtropical cyclone at 65 miles per hour at the time this image was taken, so stronger than what our system was, if that was indeed a subtropical cyclone. So, and then moving on, Patty ended up getting decoupled fully from the upper level disturbance and briefly became a tropical storm for about 6 to 12 hours before it's degenerated into a remnant low. So that is it for this video. I know that was a lot of information to digest, so if you have any questions, please ask them in the comments below, since the last portion of this video was a little bit speculative with, or what I'll just call speculative with evidence. I may not be able to answer every single question, but if I can, I will answer it. Otherwise, I will see you all probably in the next PNW Weather 101 episode because I do plan on releasing that before my December update for the winter weather outlook. So until then, stay safe out there and take care.